Hello. We are going to start with the function or not a function notes. By the end of this video, you should be able to answer the following questions. How is a function represented and what does it look like? If you remember things from last year, you might be able to already answer these questions. But if not, that's what we're here for. So moving straight forward, to determine if a graph is a function, you perform a vertical line test. No 2 points should line up vertically. So you're going to fill this in at the very, very top. You do a vertical line test. So we have some graphs here for you to practice with. If I take a vertical line and I put it anywhere on the graph, it should only cross through 1 point. This line is always crossing through 2 points, so that means it's not a function. Moving to the next graph. Here it's only crossing once, 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 once. That means this graph is a function. Your third test, once, once, uh-oh. Both of those points are in the same vertical line. That means the x value of 4 has 2 y values. That makes this graph not a function. Here, my x value of -2 has 2 y values, so this graph is not a function. So the only graph on your notes that is a function would be that second one. So you can just circle, you can put x's through it. These are your notes. Just make sure that you know the only graph is this second one. To determine if a set of ordered pairs is a function, all x values must be different. So with my first set, I have a 3 here and a 3 here. That makes this not a function. My second set, 1, 3, -1, 5, 2. Those are all different, so it is a function. My third set, -2, 1, 2, 3, 4. All different. That's a function as well. Moving on to mappings. To determine if a mapping is a function, each x value can only go to one y value. My first map, each x is only pointed at one y value, so that's a function. My second map, each x value is only pointed at one y value. That's a function. My third map, my 2, has 2 y values. That makes this not a function. Just as a quick note, it's okay here that the -2 and 7 both have the same y. That's okay. But if one x has 2 y's, that's not okay. Because remember, each x value can only go to one y value. Moving on, to determine if a table is a function, all x values must be different. This is very similar to the ordered pairs. Here, all my x's are different. It's a function. Here, all my x's are different. It's a function. Here I have 2 -1s. Not a function. The last one is to determine if a situation is a function. Decide if each x can only have one y. You kind of just have to think through this logically. Starting with 40 cents per pencil. So if I think about every time I pay 40 cents, do I only get one pencil? And that's true. I'm not going to pay 40 cents and sometimes get 1 and sometimes get 100 pencils. So thinking about every time I'm paying money, there's a set amount of pencils that I would get. So this is a function. The cost of the car and the color. I could have a car that cost $12,000. It could be black, it could be red, it could be white, it could be yellow, it could be orange, it could be purple, it could be green. So that makes it not a function. Because the cost of the car, that's my x value, could be with a lot of different colors. But in this case, if the cost is 40 cents, I'm going to get 1 pencil. If the cost is 80 cents, I'm going to get 2 pencils. If you don't see the difference, make a note so we can discuss it in class. Foot size and weight. There could be a size 8 foot, and the weight of the people with a size 8 foot could all be different. So the foot size of 8 could have different weights on different people. So that's not a function. This is the trickiest of all of them just because it's more of a logically thinking through it. You could create a table to figure it out. If you're unsure, you could think about how it might look on a graph. So this is kind of the trickiest, I would say. So now you should know that a function can be represented by graphs, ordered pairs, mappings, tables, situations, and they look different depending on how it's represented. But you will need to know how each one's represented and be able to tell the difference. That is actually it for that page. So now we're moving on to the other page that says function notation. And at the top of that little half sheet, you have to fill in all of this stuff. So you might want to pause your video to fill this in. But it says a relation is a set of ordered pairs where x is the input value and y is the output value. So relation, all that means is that your x and your y are related to each other in some kind of way. If you have a graph, that's a relation. If you have ordered pairs, it's a relation. Everything we just talked about was a relation. That whole paper we just went through, everything on there was a relation. But only some of them were functions, because a function can be thought of as a relation that assigns one output to each input. So functions are special types of relations. It's very, very important that you understand that. Everything we talked about was a relation, but functions have one output to each input. This could be thought of as one y to each x. Outputs are the y's, inputs are the x's. You guys discussed that last year, those vocabulary words. Looking at these examples, all of these are relations. This one's not a function because we repeated 4's. This one's not a function because there's only one x in all of these y's. This one's not a function because we repeated -1's. But all of these are relations because we have x's and y's put together. An equation can be solved for y by substituting a value for x. So you've done this before. Our example, y equals 2x minus 5 when x equals 3. So we want to solve for y when x is 3. Y equals 2. We're substituting the 3 in for the x. Here we're multiplying. 2 times 3 is 6 minus 5 equals y. So y equals 1. You've done this before. When using function notation, f of x names the function and replaces the y. So we just talked about y equals 2x minus 5. This is function notation. The function of x equals 2x minus 5. It's another way of saying it. We're learning about functions. So the function of x equals 2x minus 5. If you're substituting a value for x, it is written inside the parentheses to show it is an input value. Remember, x is an input. So it's the exact same thing. The function where x equals 3, you see how that's replaced with the 3, equals 2x minus 5. So that just means my x value is going to be 3. So in my function, this is my function, I replace the x with a 3. This equals 6 minus 5. When x is 3, my function equals 1. We got the same answer. This is function notation of something you already know. You have this diagram in the middle of that half sheet. So while I'm talking about it, go ahead and start writing, or you can pause to write and then listen to me talk. It's up to you. This whole part, f of x, means the output of the function f when the input is y. We often refer to this as y. Excuse me, the function f when the input is x. We often refer to this as y. So this means the output of the function f when the input is x. This is the name of the function. F is the name of the function. Inside the parentheses tells what number to plug into the function, and then the 3x plus 4 is the actual function. So let's practice. F of x equals 3x plus 4. So f of 5, that means we're replacing the x with 5, means 3 times 5 plus 4. 3 times 5 is 15, plus 4 is 19. So when x is 5, the function equals 19. You have this example on your paper, so do it with me. 3, replacing the x with 2, plus 4. 3 times 2 is 6, plus 4 is 10. So when the input is 2, the output is 10. 3 times 0 is 0, plus 4 equals 4. When the input is 0, the function equals 4. 3 times negative 1 plus 4. 3 times negative 1 is negative 3, plus 4 is 1. When the input is negative 1, the function equals 1. So now we're just kind of going to go backwards. Using your knowledge of what we just learned, what do you think you would do given the following information? So given my function, if f of x is 9, what is the value of x? So I'm saying that this equals 9. So this equals 9. So the output is 9, 2x minus 5. So now we have a two-step equation. Add 5 to both sides. 9 plus 5 is 14 equals 2x. Divide both sides by 2. X equals 7. So when my function equals 9, x equals 7. This one's on your paper. So go ahead and do this one with me. When my function equals 7, what's the value of x? 3x plus 4. Subtract 4 from both sides. 7 minus 4 is 3 equals 3x. Divide both sides by 3. X equals 1. So when my function is 7, x equals 1. This is the end of your video for today. Be sure you go to the feedback form in the comment section. Fill that out for me, and I'll see you guys tomorrow.